Students, let us take up with preparation of alcohols. Let's see the first method, and that is preparation from alkenes. As we have summarized earlier, we are going to take up with three different starting reagents being used for the preparation of alcohol, one among which is alkenes. So we are going to make use of alkenes from which we will obtain our alcohols. There are two different methods which will be used in obtaining alcohol from alkene. The first one being acid catalyzed hydration. Now know that from alkene we are going to obtain alcohol by carrying out addition of water, which is called as hydration, and this will take place in presence of a acid which is used as a catalyst, and hence it is called as acid catalyzed hydration. We take up with one simple example. Here we have propene. This is a asymmetrical alkene. What do we understand by asymmetrical alkene? That is, on either side of a double bond, we have dissimilar number of carbon. Over here we have 2, here we have 1. So this is a asymmetrical alkene which undergoes hydration. It is a acid catalyzed hydration. What we obtain over here is propan 2-ol. Understand one thing here, that addition of a water takes place to a asymmetrical alkene, and it follows a Markovnikov's rule in which OH gets added to a carbon which is forming a stable carbocation. We'll be able to understand this in a much more better way when we take up with the mechanism of this reaction. So to take up with the study of mechanism of this reaction, let us see how many steps are involved. Altogether, there are 3 steps involved in obtaining alcohol from alkene by acid catalyzed hydration. The first step being protonation of alkene. Now, what is this protonation of alkene? As we have said that the reaction is acid catalyzed reaction, what actually happens is the water reacts with the acid in order to form hydronium ion. So this is H3O positive, a positive charge being carried by the oxygen because of an attachment of a hydrogen to this. Now in this particular case, this hydronium ion then comes in contact with your alkene. Now look at it. Over here, there is this particular alkene is rich in electron density. So this is the negatively charged species, or I can say electron rich species, and thus it goes to attack the hydrogen of a hydronium ion. It abstracts the hydrogen of the hydronium ion in order to obtain this particular compound. So here the double bond opens up, giving you an addition of a hydrogen, and the other one is without a hydrogen, and hence it carries up with a positive charge. Thus it forms a carbocation. Water is given as a byproduct in this reaction. This is the first step, which is called as protonation of alkene. That is, addition of a proton takes place to the alkene, thus giving you a carbocation. Now when we have a asymmetrical carbocation, two types of carbocation may be formed. A primary carbocation, because of addition of hydrogen over here, this will be carrying a positive charge, or a secondary carbocation That is, addition of a hydrogen has taken place over here, thus giving you a secondary carbocation. Now, what is the next step? In the next step, we have a nucleophilic attack of water on carbocation. Now, what's this nucleophilic attack? Water here has this pair of electrons carried by oxygen. Thus, it is electron rich, and hence now it will be attacking a carbocation which is lacking the electrons. So, over here, this particular reaction occurs, giving you addition of a water taking place to your carbocation. But now that oxygen has formed a bond with the carbon, this oxygen now will be bearing a positive charge. What happens next? In the next thing, we just require removal of one of the hydrogen, which can go as a hydrogen ion, thus giving us alcohol. That's what's happened over here in deprotonation to form a alcohol. So, removal of a proton gives you an alcohol over here. So, this is the protonated alcohol. Water abstract the hydrogen from here, thus forming a hydronium ion and giving a product, that is alcohol. So here what we find is that in 3 steps, that is protonation of alkene, which goes to give you a carbocation, nucleophilic attack of water on a carbocation, which goes to give you a protonated alcohol, and deprotonation of this protonated alcohol gives you alcohol as your product. To summarize again, here you have to remember that a asymmetrical alkene follows Markovnikov's rule in obtaining your secondary compound as the major product.